DC, obviously, to AC is what an inverter does. In that conversion or inversion process, you require a lot of DC power to produce a little bit of AC power. It's the same amount of power, like wattage total, but a lot of DC current goes into an inverter for a smaller amount of AC current to come out of that inverter. So an inverter may be creating 120 volts AC output, right? On the input side, it's pulling 12 volts from the battery, and to get that same output wattage, you need a much higher current draw, so more input. So we need very thick, heavy gauge cables when we're installing these. It's especially important, well, I mean, it's important in every size, but as we get into larger systems like, 2000 and 3000 watt inverters, this becomes very, very important. So cable length, how tightly those cables are actually connected, so the quality of the connections, and then the fusing as well is incredibly important. You want to make sure that you're always using T-class fuses, not just a standard A&L fuse, because they don't have the same protection really as a T-class fuse does. So critically important with like 2000 and 3000 watt inverters and up from there, always make sure it is a T-class fuse that is used. That will protect against catastrophic system failure, and a standard A&L fuse will not provide that same level of protection.